Hi everyone, I am Nived Verma, Microsoft Certified Trainer. In this video, we will explore fundamentals of machine learning. And during this video, I will explain about the machine learning in general, and then we will focus on Azure Machine Learning. First of all, let us try to understand what machine learning is. Machine learning is one of the very popular buzzword in the modern technology, and you will hear that machine learning is used for creating artificial intelligence. Let us first of all explore the very basics of machine learning. A machine learning primarily deals with creating predictive models by finding the relationship between the data. For example, a botanist collects some sample of flowers which are of different colors and textures, and each sample that the botanist collects has a set of features or characteristics and the label, which is the species. You can see here in this graphic that there are different types of labels which are associated with different samples which are there, and they are on the basis of the characteristic. In machine learning, an algorithm will be used to find the relationship between the feature and the label. That means, what are the characteristics that can be used for predicting that what will be the species of that sample. Now, when we combine this piece of information in the algorithm, it is called as a model. Now, this relationship is stored as a model, and this model can be used for predicting the label of a new sample based upon its feature. For example, if this flower is given to the model, or an image of the flower or the characteristics are given, the model can predict that this is a Bellis paranesis. Now, each and every machine learning model will have to be refined, and it is always the uh, goal of the data scientist to make sure that the models can predict as accurately as possible. Now, these kind of algorithms are popularly used in statistics even before the computers came. Let us try to understand the different types of machine learning and how exactly the machine learning algorithms are used while making or creating such models. The machine learning is of two types: supervised machine learning, where you already have the training data, which includes the labels. Labels, in other terms, the predictions. And in this, we have two types of algorithms which are used: regression, where a label or prediction could be a numerical value. So we can predict the number of bikes rentals based upon a day, season, and weather. The other type of algorithm which is popularly used is classification. Remember, regression and classifications are already there in the branch of statistics. So classification label is for categorization. Now, we can use some data and predict whether a patient is at risk for diabetes based upon based upon the clinical measurements. Now, in this case, our data set already includes the result of those findings. So this is why it is called as a supervised learning. In unsupervised learning, the training data is unlabeled. That means we will not train the model with the data which is having outcome or the label already there. And the algorithm or the method that is used is called as clustering. Clustering is nothing but when we group similar items together. For example, we can group together vehicles with a similar emission and fuel efficiency characteristics, etc., into the separate clusters. So when you think about machine learning, these are the two primary ways in which the machine learning models are created. Let us explore a little bit more on this. As I said, regression is one of the ways by which we can predict something that is available to us. And regression is a well-known statistical technique to model the predictive relationship between the several dependent or predictor variables and one dependent or predicted variable. For example, in this graphic, you can see that we have used two pieces of data: training and validation. In machine learning algorithms, we always use some from the larger sample. We divide the data into training and validation, And then we train the model so that the model is able to understand the relationship between the variables. And then we validate that model, that how accurately it is predicting, by means of giving it another set of data. Mind you that at the time of the training of the model, the validation data is not available to the model or to the system. Like in this example, when X is a variable which is nothing but the temperature and Y is the rental bikes, how many bikes were rented based upon the temperature, a regression is used to understand the relationship between them. And when validating, we can say that when the temperature was 54, it predicted that there will be a rental of 114 bikes. However, you can see that this is where the original value for 56 temperature or 56 degree Fahrenheit or Fahrenheit temperature was there, and at that time 115 bikes were rented. So this prediction of having when the temperature is 54 degree Fahrenheit and 114 bikes will be rented, it is a good match. Similarly, for other values, it is nearly matching the actual values which are there. And you can see over here that this particular thing has been drawn as a graph in this case, which is called as a curve or regression curve. And you can see here that we have this y-axis which is containing the cycle rentals, and here is the temperature. And we can understand here that there is an interception of the data between the temperature and cycle, and we can come to know, and we can then predict if the temperature of today is X, then how many cycles are going to be rented out from my store. Now this could be something very useful for the business. The other type of algorithm which is there is classification algorithm, in which we can see here that there is a X and Y variable, and in Y we are predicting whether that person is at risk of diabetes or not. In X column you can see that here we have several values of X, 4 to 3.2, 10. These are nothing but some kind of medical findings which are there, and these are the classification which is either 0 or 1. 1 means they are at risk of diabetes. 0 means they are not at risk of diabetes. So classification is like sorting things into labeled bins. You teach the algorithm what different bins look like, and it figures out how to sort the new thing into the correct bins. The other example which we often see in our email boxes is that when we have a bunch of mails and some of these labeled as spam and others as not spam, a classification algorithm can learn from these labeled examples, and when a new mail arrives, it can predict whether it is a spam or not. Now, such type of algorithms are used widely in the industry for classifying a mail or a document or anything for that matter that is labeled, and then we want to put that into a particular bin. You can also run your imagination to identify some real-time scenario where classification algorithm can be used. Going forward from here, the other type of algorithm is called as clustering. And in clustering, we can see that we are going to group together some of the some of the samples based upon their characteristic. But do remember, clustering is an algorithm of unsupervised learning, which means at any point of time that the information is not known, or the data or the data is not known, data, the result is not known to the computer. So it is an unsupervised learning. Clustering is one of the algorithms which is very useful in scenarios where you don't know the outcome. Like for example, we can imagine several scenarios like if you don't know the outcome of certain features of flowers, whether it will be of this species or that species, then in that case we can come to know that maybe on the visual characteristics or some data characteristic, we can cluster them together. So these are the different type of algorithms which are used in supervised and unsupervised learning. After understanding these fundamental algorithms which are used in machine learning, let us try to understand that how exactly the machine learning models are trained and validation is done. The very first step in doing this activity is to take this step number one, which is splitting the data into training set and validation set. And then we will be applying, once this separation is done, this is the two sets of data from the sample data, and then from apply the algorithm to fit the training data to a model. And once this model is ready, the model will generate some predictions from the validation data. So what we do here is that from the validation data, we try to see if our predictions are matching, because we already know the outcome of it. Then we will use something called as a valuation matrix to compare the predicted versus actual labels, or measure the cluster separation in unsupervised and supervised learning. So we use the model to generate predictions from the validation data. So you can see that this is where it is, and then we are going to generate the outcome over here, and then we will be able to use the evaluation metrics to compare the predicted versus actual in both the cases, supervised and unsupervised. And we will keep on repeating this process unless and until we are satisfied that our algorithm is able to predict as nearly as possible, as in from our validation data set. We can refine the algorithm. There are several ways of refining the algorithm. One of the terms you will often hear is called as hyperparameter. Maybe if you attend a full-fledged course on machine learning, these things become much more clear to you. The purpose of this, video or this explanation to make you aware of the terminologies and how exactly these terminologies relate with artificial intelligence later on.